Hi folks, you might remember from the olden days these kind of vacuum fluorescent displays that used to be about in the sort of 1970s and 80s. This one came out of a cooker clock. If I just pull this to pieces, get a better look at it. Specifically these kind of displays that have now been replaced by LED things. I was recently looking on eBay for something interesting, just a little fun project to buy. And I came across this thing that's sold by Kosbo.com, I think, Kosbo.com, and it's a VFD clock, circuit board and bits, but instead of the normal kind of digit display, let's just crack into this, we've got this really rather interesting segment display. Get it the right way around. So I shelled out on it. It was a bit more expensive than normal, but it's a pretty unique item. I've never seen a clock like this before, so I thought I'd put this together and just build the kit up. It's a kit with all the parts. I thought it'd be a nice little fun soldering project for me, and then I can either 3D print or maybe woodwork up a case to go with it. So let's have a look and see what we got. So this kit comes with some pretty good documentation which I've downloaded from the website and printed off, but we've got circuit diagram, we've got the full component list, some assembly instructions, user manual for how to actually do it and what the buttons do when you press them, a blank sheet for no reason, circuit board layouts, and there we are, that's the one, dimensions for actually making a case, so that's going to come in useful. I'll probably 3D print something first off, but I might feed something into my woodworking router and see if I can make something more attractive out of a nice hardwood later on. Anyway, I thought before I get stuck into that, I'd have a play around with this one, because I've had this sitting around in a junk drawer since I was about 18, so we're talking, I've had this kicking around for well over 20 years now. Anyway, I'm going to desolder this and see if I can get it to display something. Now these displays are actually not too difficult to get working. You don't need any particularly high voltages. In this particular one, I don't know if you're able to see here, I can actually enhance that. There's a bunch of filament wires that run across here. Hopefully we can see a bit of a red glow there now. Let's just up that voltage a bit more. There we go, you should be able to see those. And those basically bubble off electrons that make their way to the elements. So I've got 3.3 volts across there at the moment, and if you run 12 volts across the various pins, then you get the segments to light up. So a lot less hassle to drive than Nixie tubes and things like that. Really quite a nice bit of technology. It's kind of a shame they went out of common use, but they did fade out after time, though this one still looks fine. Anyway, I'll get on with building the kit. So here's all the goodies. Let's take a look at what we got with this thing. So quite a nice sort of bluey green circuit board, and he's already soldered on all the surface mount devices, so it's just standard through hole soldering. And hopefully it's got a good silk screen on there so all the different component values are filled out. So I just need to match up the components listed on the component list with their positions on the circuit board, and I've even got a nice large version of the diagram of the silk screen to help. So I'm going to get my soldering iron out and do some through hole soldering for an hour or two, or half an hour, see how long it takes. I'm not going to bore you with watching that. That's all the components on there, and I think I got everything right, and I'm reasonably pleased with the outcome. I'll clean off all this flux at the end of it, but I think I got everything right. I think I got all the right components. There were a few errors on the data sheet or on the component list. So it lists we had a 760k resistor, it was actually a 680 that was shipped. 470U capacitor was actually a 200, and it said we had two of these 33 picos, but I actually received a 33 and a 22, so I swapped in spare one of my own 33s from my own stock. So I haven't soldered the VFD on yet. I'm working through the instructions, and it says before you solder it on, hook it up to a 12 volt supply and make sure it's pulling about 7 to 10 milliamps. It's a good time to check your voltages. I've got my power supply limited to 100 milliamps max, and things aren't going too well, because when I hook things on, we're pulling 100 milliamps there, and the power supply's dropped down to 3.7 volts at the moment. So clearly we've got some problem that I need to work out what's gone wrong there. So I'm going to check through everything and see if I've got something wrong, but I was very confident that I'd got it right. So really not sure. Time for some debugging. Okay, so time for a bit of troubleshooting 101 then. First thing I want to check is the resistance across the input on the power pins. So I just hooked that up. We got 70-80k. That's not unreasonable. That certainly looks right. If I just reverse the probes, we get nothing at all. So and that would seem to indicate the fact that resistance is slowly going up. Yeah, certainly there's nothing there that's effectively a short circuit, so that should be alright. I'm just taking a look at the back of this board. There's nowhere obvious that I can see that I've got any short circuits on my soldering, nor on the surface mount devices there. Certainly all looks okay. And checking the component placement a little bit, I've got the little cutout corner on this transformer where the cutout's indicated. Definitely got my capacitors the right way around. Transistors are all in there. So I think it's time for me to take a look at the circuit diagram and see if I can work out where things might be going, because I suspect something's starting to switch on at about 3 volts or so, and maybe I've got a problem with a transistor or with a voltage regulator or something along those lines. So yep, time to look at the circuit diagram. Okay, so here's our circuit diagram of the whole thing, and the bit we're actually interested in is down in this corner. Let me just make that bigger for you. So over here on the left hand side, this is where we've got our 12 volts coming in. We go through a fuse and get stored on a couple of decoupling capacitors, and then we go into our voltage regulator, which gives us out a regulated 5 volt supply, and then we've also got our battery backup circuit here with the CR2032 lithium cell, which is sat down here, and a diode to make sure, I think it's Zener diode possibly, or a diode certainly, to make sure that that battery doesn't charge up from this when it's at 5 volts. So that's our backup battery, and that's not in circuit at the moment. I could try removing this jumper and see if it makes a difference. Perhaps I've got a diode the wrong way around, but I mean, anyway, this coin cell's not connected, so there's no path to ground there, so I can ignore all of that. Don't need to worry about that. But we should be getting 5 volts out of there, and we seem to be getting to about 2.5 volts, and then our current's dropping off. So I'm going to have a look around this. I might desolder the voltage regulator and confirm what's going on with that. And anyway, I'll carry on, and then that 5 volts then comes in over on the other side of this diagram here. This is the same 5 volts coming in, and that feeds into the chips and the push buttons as pull-ups and things like that. So that's our main logic supply there. There's also, up in this corner, our little switcher that's generating our negative voltages for the supply. I think we get minus 26 volts out of this little circuit with the transformer here. Yeah, I believe that's all driven from the 5 volt supply anyway. So I'll have to check that. It's easier to see the diagram on the screen of the camera than it is for me to see it in real life, and since you're viewing this at 4K, you're probably screaming at me going, oh, the writing up here says this. I can't read that at the moment. But anyway, I'm going to take a look in more detail, see if I can work out where the problem is. I've been on a hunt around this circuit board for short circuits with my multimeter, looking for things that were 0 or close to 0 ohm resistance. All of the transistors seemed to check out fine, none of that. But around this little transformer at the end, there were some very low resistances, like 0.2 ohms, things like that. So I thought I'd desolder that, and I think the low resistances I was seeing were just in here. I think that's just 2 or 3 turns in some of those windings, I'm not really sure. But now when I hook the power on, this thing draws almost exactly 100 milliamps on the dot. It's no longer pulling the power supply voltage down, it's sitting at 12 volts and drawing 100 milliamps. And that's about a watt of heat going into this thing somewhere. So I did the lip test and pressed various bits of the circuit board to my lips to see what was getting hot. And this transistor over here, T2, is the one that's getting hot, and T2 is this one here on this circuit diagram. So I'm going to be checking my resistor values, and I'm going to have a probe around this area and see what's going on. There might be a problem with T3 as well. So yep, time to get investigating further. Okay, so this 100 millivolts that I'm seeing is actually quite deceptive. There's a 120 ohm resistor there, which means when this transistor's switched on, there's 120 ohms between the 12 volt rail and ground there, and of course 120 over 12 is 100 milliamps. So that's why I'm seeing 100 milliamps on this circuit now, but that kind of nicely proves that the 5 volt rail probably doesn't have any shorts on it, and I'm onto the right kind of track around here, but it's kind of, maybe there's something wrong on this side, maybe there's something wrong in this transformer itself. I don't know the number of windings on anything, I don't know what the resistance is supposed to be, but the fact I'm seeing 100 milliamps draw on this thing now is, yeah, it's almost certainly all the current's going through that resistor, which is not even on the screen, tucked away down here behind this capacitor. I wish I had one of those FLIR thermal cameras, that would come in quite useful at the moment. I've desoldered T2 now as well, and that checks out as being okay. It says it's NPN bipolar transistor, pinout's right, current gain's about right for a BC 639. So that all checks out okay. Now without that in, the circuit's actually pulling 5 milliamps now, so I've definitely disconnected whatever's going wrong. Okay, so a little more debugging being going on here. I've been probing around, I haven't actually got these soldered in, they're just pushed to fit, but they seem to make a connection. So I've put the transformer and T2 back in there, and I've been probing around things with my oscilloscope, watching where the frequencies are. So I'm totally happy, my 5 volt rails are fine, my clocks are fine, I can see the 4 megahertz going into there. I can see something around 350 kilohertz driving the clocks on this chip as well. This is just some output driver, I'm guessing. That's all alright, that's working. With these two back in, our current draw goes way up again, but I can actually see frequencies on here. I can see kind of up to about minus 68 volt peak coming off there. We are switching this transformer. This transformer is doing its job, and doing the what bits are hot using my lip test again. This little capacitor here seems to be getting hot, and there's no reason why it should that I can think of. So I suspect that might be our dead component. I'm going to whip that out next and see if that makes everything go right. So I've whipped out C11, and I noticed that this is a 10 volt rated capacitor, and this is for the minus 26 volt rail. And I also noticed that I've cleverly got two of the capacitors the wrong way round, and that this is the 63 volt rated capacitor there. So I've managed to put two in the wrong way round. So hopefully once I fix that, we'll be in business. So finally, after many hours debugging, we're working, we're pulling 14 milliamps, we've got a good 5 volt rail, we've got a good minus 26 volt rail, everything's looking positive. Now I'm ready to solder the display on. If only I'd checked the capacitors better the first time around. Easy mistake to make, took me a long time to find, but the find out what's getting hot with your lip trick has proved its value once again here. Well, we're all up and working now. Excellent. The camera doesn't really do this thing justice. It's a beautiful, sharp display in real life. The camera makes all the numbers and the hands look a bit blurry. And there's a couple of different modes on this thing. I don't really understand what it means, but it puts a white dot there. I think that's setting one of the alarms. So it's like 6:15, and another one at 8, I'm guessing. And yeah, so next up, oh, that's better. So next up, I need to build some kind of case for this thing, but that can wait for another day because it's 11:25 right now. So my first attempt at making an enclosure for this clock didn't work out too well. I thought I'd use some cherry that I'd cut down in the front garden a couple of years ago and had just been sitting in the log store, but after sawing it up, thicknessing it, planing the edges, making it neat and tidy, I realised there were just too many cracks throughout the wood. It just wasn't going to be usable. There was no way I could get it to the right sort of dimensions. So instead I've dug out this fairly thick piece of, I don't know what this is, mahogany, something like that, teak, I'm not really sure, but it looks alright. It'll look quite good when it's got a nice surface on it, and most importantly it's thick enough that I can fit the whole body of the clock inside and still have a fascia on it, so I can make something fairly thin. I'm not really sure how the design's going to work out. I need a 40mm hole in the middle, and I've got the dimensions. I need a 55x70 cutout for the clock body to sit in behind that. So I'm just going to cut a hole through there on the drill press, round the edges off with router bits, route out a square in the back, and then try and cut some nice looking shape out of it. So I'm going to use this chamfering bit to smooth off the edge of that corner there to make it a bit less harsh. I reckon that'll do nicely. Now I just need to mark out and cut out a square from the back side of this, which I shall do right now. Now, in order to cut out the square in the back where the circuit board's going to sit, I'm going to use this contraption that I built 7 or 8 years ago, I can't remember quite when. And this is my CNC woodworking router, which is built out of rack mount server rails and, don't know if we can see any, threaded bar and some stepper motors. And round the back we've got a bunch of electronics that controls it all. Power supplies and stepper motor controllers, and that hooks up through a parallel port round to this very old laptop, but it does have a parallel port, which is what I actually cared about. So I can use the keys on the keyboard here to move things around, and this gets things in dead straight lines. So just have a look there. So just the motor spins the threaded bar and that moves things around, and it can move the router up and down as well. See, we're dropping down there. And this system speaks a language called G-code, when I press the right keys. And I'm just going to knock together 4 or 5 lines of G-code, which basically just tells it to go to coordinates. And I'll knock together the right 4 or 5 lines of G-code to get this to draw a square for me. Turn the router on and it'll sink down into the wood and cut out a square. This is what G-code looks like. This is the language this thing speaks. F tells it the feed rate, so that's 600 millimeters a minute, I think, or something along those lines. G0 is go quickly to some coordinates, and it's got X, Y and Z, and then G1 is go slowly, which is when it's actually doing the cuts. And that just traces out a square, and if I run that, there we go. Obviously it's not cutting right now, but it's I'm going to turn the cutter on in a second and change the depth, and it can go through and draw some squares for me. hopefully that display is in the centre, because it's going to be a pain if I have to adjust this after. And conveniently I got it just about the right height that the buttons will poke through at the back, so not bad. I've got a bit of lateral play on there, which is good. Anyway, I'll take the clamps off this and see how it looks from the front. So we're not quite perfectly lined up with that hole, so I'm going to have to make a bit more space at the back so I can get that alignment spot on. Okay, so we've got a bit of wiggle room there now, and that looks much better from the front. It lines up properly at some position in there. So now I need to think about how I'm going to shape some kind of curves around this to make an actual clock shape thing. The pencil marks show up on here okay, but I think that's what I'm going to go for. Looks good enough for me. It'll do for a Monday afternoon's work. So I'm just going to whiz across there with the table saw and then take this out on the bandsaw. Not looking too bad, so I'm going to put a round over on the front edge there, 1/4 inch round over or something like that. So the next thing I want to do is just take it so it angles back a bit. So I'm just going to, I don't know whether to use the planer or the table saw. I suppose I can just angle the blade on the table saw and slice a bit off there so that it'll sit leaning back slightly. And then it's just cleaning up, tidying up, lots of sanding, and I think then we're good to go with a coat of varnish or wax or something like that. Beeswax, something. Work it out, see what I've got left. I'm just going to angle the fence on my planer back to something like about that angle, and then when I pass that over I can plane away at the bottom. Let's give that a try. I'm going to treat it with this Danish oil purely because I've got it already and I don't have to go to the shops, and it seems to be this or French polish, and I haven't got the patience for French polishing. We'll see what we can do with this stuff. Hopefully this will look alright. And that looks alright. Now, although I should wait for the varnish to dry, I'm too impatient and I want to get this video finished, so let's see how it looks. So, here we have the finished article, and with the buttons on the back I can adjust the brightness of it. I keep trying to get a decent looking shot of this on the camera, and whenever I do it makes the digits look far too bright, so I'll have a play about in a second and just see if I can get one final one. But anyway, that's it for this video, folks. Hope you enjoyed it. Bit longer than normal, bit of woodwork, bit of electronics, bit of building kits, bit of debugging, Mixture of all sorts of things. Anyway, if you enjoyed this one, thumbs up's always appreciated, and if you've got anything to say, pop it in the comments down below, and I'll get back to you sooner or later. I've been very bad about replying to comments lately, really sorry. Anyway, cheers folks, I've earned a beer now, I'm off for a beer. See you next time, thanks for watching, bye!